And Tanzuru asks a really good question. I think this gets at something that we should talk about to get started. Why is log needed? Right? I mean, I made some historical allusions here, but why would we even need a log at all?
Yeah, I think that's an excellent question, and for me, it's connected to an idea of functions and the inverse of a function. If you scroll over to those number lines that we were looking at the last time, Zach, we could take, for example, 3 to the x as a function. And in blue, we had the input numbers, so 0, 1, 2, 3, and 4. And in black, underneath that number line, we have the output values, 3 to the 0, which is 1, 3 to the 1, which is 3, 3 squared, which is 9, 3 cubed, which is 27, and 3 to the power of 4, which is 81. And we might find ourselves in a situation where maybe we have 3 to some value is equal to 15, right? 3 to some unknown value is 15. I'm looking at my number line and I'm like, okay, well, how do I figure out what my input has to be in order to get that output of 15? It's not obvious where that lands on my number line because my inputs are all positive integers. Mm-hmm. So the logarithm helps us connect the gaps that we have in our number line. It helps us find real number approximations effectively to those input numbers. So I know that 3 to the something equals 15 is going to land somewhere between 2 and 3 because 3 squared is 9 and 3 to the 3 is 27. Maybe a little bit closer to 9, maybe a little bit closer to 27. We can argue about that. But, maybe it's something like 3 to the 2.5. I'm just making some number up, right? I'm just making a guess.
Well, this is a
but that's what the logarithm does. It helps us figure out that problem.